Hi friends, my name is Shivam and today we are going to discuss another data structures problem. So the problem we are going to discuss today is, given an array, we need to find the count of sub-arrays with given sum. So this is also a very popular interview question and asked in many technical interviews of various companies like Amazon, Microsoft, Uber, Adobe, etc. So I'm taking up this question because this question has multiple variations. So the question I told you is given an array, you need to find the count of sub-arrays with given sum. So the variations can be, given an array, find the count of sub-arrays with sum 0, and given an array, find the count of sub-arrays with equal number of ones and zeros. Given an array, find the maximum sub-array with equal number of zeros and ones. So and so on. So the list goes on. So if you are able to solve this question, then and you know the solution very well, like how the solution is derived, and you know the solution thoroughly, then you will be able to solve multiple other such questions which are similar to this question, and that would help you a lot. So that's why I took this question. So before moving to the solution, as I suggested you in the previous video as well, you should ask the interviewer all the questions you have in mind. So since the input set is not clear, the size of the array is not clear, so you should before attempting a solution, you should clarify all these doubts you have in your mind from the interviewer, and this creates a positive image of in the interview mind. So keep a note of it and always ask the questions you have in your mind. Don't hesitate. Okay, so now let's move on to the solution. So if I think of a naive solution, the basic solution which comes to my mind for the first time is I need to find the sub-arrays with given sum. So what if I'm able to find all the sub-arrays, and I find the sum of all the sub-arrays and just match it with the given sum. So if the sum of that sub-array matches with the sum I want, I can just increment my result count. So that is how I can attempt the question in naive way and at least have a solution. So as I suggested in my previous video as well, so you should always start with the naive solution. Never jump to the optimized solution, because what happens is when you are attempting the solution using the question using naive solution, the brute force solution, you take care of all the aspects, like all the edge cases, the possibilities and all. So, and once you have this working solution, you gain some confidence. So that's how it helps you proceed in the right direction and find out the optimal solution. And also one more thing which you might not know, but I can share it from my experience. Once you have a working solution, so either be it brute force, when you have a working solution, the interviewer also helps you. Like he starts giving you hints and he helps you move towards the optimal solution. Interviewers are there to help you. So they never want that the candidate should not be able to solve the problem they give. They always want that the candidate should be able to solve the problems, and they give every possible hint for that. But if you are struggling and found nowhere, then they can't also do anything. So if you have a working solution and you have solved the question, then they start giving you hints. Like they show you, they give you hints like you can use this data structure, or you can use proceed in that direction. And using those hints and ideas, you can reach the optimal solution. So always move ahead with brute force solution, have some and then gradually move towards the optimal solution. Okay, so I think the brute force solution is clear to you all. And if you still have any doubt and wants to see the code or pseudocode, you can visit my previous video about the topic, the maximum contiguous subarray, wherein I explained the brute force algorithm and also shared the code in my blog post. So I'll be sharing the link for my blog post in the description, and also the link to the previous video. So you can refer to that for the naive solution. Now let us understand the question more. So because as I told you in my previous video as well, so there is always some trick. So there is always some hint, a key factor in the question which you need to find out and use that to reach the optimal solution. So everything is present in the question. There is no magic you need to find out and to reach the question. So since the question says you need to find all the sub-arrays with given sum, so you need to play with sum. You need this sum property to reach to the optimal solution. So let us, I'll show you the example, and then which will help you reach the optimal solution yourself. So let us understand the problem more. So suppose we are given this array. So we need to find all the sub-arrays with given sum. So let us use the property we used in the previous video. So let's calculate the sum of subarray ending at that particular index. So if we are able to find out the sum of subarray ending at that particular index, then we might use that property to find our solution. So let's see. So before the array, so at the initial point the sum is 0 because nothing is in the array. At this point of this first index, the sum is 4. Here the sum is 4 minus 2, that is 2. Here the sum is 1. Now the sum is 2, 0, 3 and 0. So this is the basically sum of subarrays ending at a particular index. Now what if I ask you, for example, in this array only, I ask you find all the subarrays which have sum 0. So take a minute of your time and using this example, just manually find all the subarrays which have sum 0. If you are like, and then find the pattern. If you are able to find the pattern, then you will be definitely able to find the formula and the exact solution we are looking at. So if I ask you the solution, the subarrays with sum 0, so see, so the sum here the sum is 0. So this is a subarray with sum 0. Now we have some 0 here as well, so this is also a subarray with given some 0. Now if we see this also, like the complete array is also a subarray and it has some 0. Do you see any more example? Take your time and see any more example. What if I say this is also a subarray with given some 0? So were you able to figure out why I have marked this is also a subarray with given sum? Because this is -1 and 1 and sum is 0. So do you see a pattern here? Like, okay, take another example. I have another array and I say the sum of all the elements from here to here is x, and sum of all the elements from here to here is also x. And then I find out, then I ask you like, what is the sum of all the elements from here to here? It's quite clear, like the sum of all the elements from here to here is x and sum of all the elements is also x. So naturally the sum of all these elements need to be 0. Clear? So this is the same property I used above. So the sum of subarray from here to here was 2 and the sum of subarray from here to here also was 2. So that's why all the elements from here to here the sum is 0. So let us now create a table and solve this problem using that table. Then you will be able to understand it more. So basically I'll have a sum, I'll have a count, and I'll store the sum and the count of that occurrence of all these sums in the array. So basically before starting the array, the sum is 0 and I have seen this sum. Basically this count variable is how many times I have seen this sum in the array. So till now I have not started, so the sum 0 is once. So I have seen this sum as 0 at once, not again. So now I am at index 4, so the sum is 4 and the count is 4 because the sum of any subarray being 4 is also the first time. Now my sum is 4 minus 2, 2. So 2 is also coming first time. So the count of subarrays with given sum 2 is 1. Now what's the sum for this? Sum here is 1. And 1 is also occurring first time, the count is 1. Now the sum is 2. So we already have an array present who has sum 2. So now this should trick you. So as I told you, like using this example, if the sum of subarray here is x and again is x, so this means the sum of all the elements from here to here should be 0. So it is clear, like you have already seen a subarray with given sum 2. Now you are again seeing a subarray with sum 2. This means all the elements from that point to that point, from this point to this point is 0. So this you can increment the result count to 1 and you can now increment the sum count to 2. Okay, so now here the sum is 0. So again you are seeing the sum is 0. So this means the initial sum was 0 and the sum here is 0. So this means all the elements between these two days sum is 0. So we'll increment the count by 1 and increment the count of sum 0 also as 1. Now again, so here the sum is 3. We have not seen the sum as 3. So it will be 1. So again the sum is 0. So what now? So basically I have seen the sum of subarrays as 0 twice. So what should I update the result with? Should I update it with 2 or should I update it with 1? So the motive of keeping the count of subarrays was, let us understand it here. So basically all the subarrays we given sum 0. So this was 1 and now again I am seeing the 0. So why I asked you to keep this count is basically there are two possibilities. One possibility is this and another possibility is this. So basically this 0, the sum being 0, will form a subarray of sum 0 with all the subarrays which ended with sum 0. So this was the one array which ended, this was one array, and had it been another subarray which ended, so it would have made a subarray like here also. So that's why we need to keep a track of all the count of subarrays of that sum and add it to. So basically I'll add 2 here and increment my count of sum as 1 and 3 for next. So basically now my output is 4. So in this example I have 4 subarrays with given sum 0. So this one subarray is this, one is this, and one is this, and one is the entire array. So these are the 4 subarrays. So we were able to find out all the count of subarrays with sum 0. But that was not our original question. So we solved a very specific question, but now we want to generalize the solution to take any number x and find all the subarrays with sum x. So let us see and generalize the solution. So suppose this is my array and I know the sum of subarrays till here is a, ending at this index is a, and sum of and this is my x basically. So this is the subarray I am looking at. So I need all such arrays with end x, and I'm at this index, and suppose let's say the sum of all the elements at this index is b. So what are the chances, like how do I so when can I say like there is a possibility of subarray with sum x? So there is a possibility of subarray with sum x only if there exists one or multiple subarrays with sum b minus x, that is a. So if there are one or more subarrays with sum a, I can definitely assure that there are subarrays in my array with sum x. So that's how we derive the solution. So given an array and a number x, I need to find that how many subarrays keep with sum x. So I just want to find out is there a possibility, like do we have an subarray with sum b minus x, and what is b here? B is just the sum of current subarray. So if there is a subarray which has the sum current the current sum minus x, then we can easily say that that the particular array has the sum x. Now let us solve the question, the original array with a given sum x. So let's say the x is 2. So we need to find all the subarrays with sum 2 in this array. So my x is 2, and I know basically the sum is 0 before the starting. So I'll update the sum as 0, and I have seen the sum as 0 as once. So now at this index, what is the sum? 4, and the count is 1. So at each index I need to check if there is subarray before that whose sum is the current sum minus x. So my x is 4 and current sum is 4. So I need to check, do I have array with sum current sum minus 2? So do I have any array with sum 2? No, I don't have. So my result will be 0. Now moving on to this index. Now what's the subarray ending at index this? It is 2. So and the count is also 1. Now I need to check, do I have a subarray which follows this? So basically my current sum is 2 and my x is 2 and 0. So do I have seen any subarray with sum 0? Yes, I have seen. And what was the count of that? 1. So I will update this count in my result. So my result becomes 1, and I update. So this is I update. Now moving on to the next. Here, what is the sum here? 1. And do I have seen 1 here? No. So I just make the count as 1, and again applying the formula 1 minus 2 minus 2. So do I have seen minus 1 as count of subarrays anywhere? No. So I just move ahead. Again, now again 2. So I have already seen 2. So I'll just update it with 1. And again applying the formula. So 2 minus 2, that is 0. So do I have seen sum as 0 in my subarray? Yes, I have seen, and the count was 1. So I'll update my result with 1 again. So okay, moving on to this index. Now my sum is 0. And do I have seen sum 0? Yes. So I'll update this count and then apply the formula again. So my sum is 0, my current sum is 0, and my x is 2. So minus 2. So do I have seen minus 2 as sum? No, I'll move it. 3. So I'm not seeing 3, I'll just put it 3 here, 1 here, and now I again apply the formula. So basically my current sum is 3 and my x is 2 and 1. So have I seen the sum as 1? Yes, I have seen. What was the count? 1. So I'll update my result with 1. Okay. Moving ahead. So this is 0. Have I seen the 0? Yes, I have seen. So I'll update it. So now my count of sum is 0 and I check again. So my current sum is 0 and my x is 2 and minus 2. So have I seen it minus 2? No. So basically no. So my answer is 3. So in this array, the number of subarrays with given sum 2 is 3. And what are those subarrays? So basically this is one subarray, this is one subarray, and this is one subarray. So if you didn't know about this solution, it would be look very tricky. Like this question looks very tricky when you don't understand the question, because like there are a lot of possibilities of subarray, finding subarray, and you cannot find the number of subarrays in linear time. So that confuses you, and like you are not able to, and you don't understand like how can you solve this problem in linear time. So you need to follow this solution to find the result. So before writing the code, so before moving to writing the code, let me ask you, like what data structure would you use to store that the count and sum? So take your time and like think which data structure suits here. So I think hash map is the most suitable data structures, because you can retrieve from hash map in constant time, you can store the hash map in constant time. So that saves, that does not includes any extra complexity to the problem. So hash map is the most suitable data structure to do that. So the code is very simple. You need to iterate towards the array, and at every point you need to check if there is a entry in the hash map with sum, the current sum minus x. If there is an entry, you need to update the count result, and if there is no entry, then you need to check like does the current sum, like are there any other subarrays with given sum. If there are any subarrays, you need to update the count, and if there are no subarrays, you need to just put a new entry in the hash map and update the count as 1 and iterate it towards the entire loop. So this is just a simple code. You can write the code yourself, or if you want help, you can refer to my blog post. I have pasted the link in my description and you can use that. So I told you, there are couple of variations of this question. In the starting I told you, you are given a subarray, find the number of subarrays with given number of ones and zero. So let us understand the question. So the question is like, you are given a subarray of ones and zeros. So the array contains all ones and all zeros. You need to find all the subarrays which have the equal number of ones and zeros. So let us have a look. What would be the answer here? So one is this, one possibility can be 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 this, and one possibility can be this, and so on. So this, like there could be couple more of subarrays with equal number of ones and zeros. So this looked tricky, right? So can you solve it in linear time? Can you use the solution we implemented for this problem to use here and solve this question? So take your time, think for a while, and see if you can apply the same solution to this problem. Yeah, so you can apply the same solution here as well. What you need to do is you need to traverse towards the array and replace all the zeros with -1. So what will our array will become is 1, -1, -1, 1, 1, 1, -1, -1, 1, -1. So now what the question translates to, so you just need to find all the subarrays with sum 0. So sum is 0, equal number of ones and zeros, sum is 0, equal number of ones and 0, and so on. So you are able to translate the question of finding all the subarrays with equal number of ones and zeros to given sum. So this is how you approach the questions in the interview. So I hope you understand why I took this question, because it has multiple variations, and just keep your mind open, just keep your mind broad, and try to apply all the logics, all the possible solutions, and all the possible thinkings you have developed over the time practicing the questions in the interview. Keep learning.